What's up, everybody? This is Matt Brown with another IoT hacking video. Today, we're taking another look at the SuperBox device. This device offers customers free access forever to unlimited movies and TV shows. All you have to do is follow these instructions that are included in the box and download a custom app store from China. Does that all sound a little sketch and too good to be true? Well, yes, it is. My name is Matt Brown, and on this channel, we like to take apart devices like this, figure out what is working on the inside of these things. And if that sounds fun to you, go ahead and hit that subscribe button. And what we're going to do today is we're going to be looking at that Android application, and we're going to do a little bit of a drag race. Me against AI. So if you've watched some of my previous videos, you've seen this tool that I've released, my IoT HackBot. This is a set of custom tools and Claude skills that interact with those custom tools and open source tools to automate some security analysis of IoT devices. Well, I've just added 2 new skills in this most recent commit here. And so I've added skills for APK tool and JADX. These are tools for unpacking APK files and decompiling APK files, respectively. And we're going to use those manually and in a race against Claude Code as it uses these skills to reverse engineer and see if there's anything malicious going on in this APK file. So we're going to first go over to our workbench and look at the sketchy set of instructions. Well, the redacted version, at least. So this is what ships in the box. It's clearly just like printed out on a piece of paper. Down here, it tells you where to like follow, like, and subscribe, which I'm not giving them credit for sure. And then it gives us some instructions, a whole bunch of stuff. But the main thing here is it gives you a URL, and I'm not going to show that. And it tells you to go and install this custom app store at this URL. And then the really funny, my favorite part about this whole set of instructions is down here, like the if it's not working thing. It's like, hey, your internet security is likely blocking an IP address. Turning off, lowering your security, or giving these apps permissions will resolve the issue. That always sounds like a great idea. And then they're like, oh yeah, if it doesn't work, just like use a VPN. Yes. That will really help their malware to work if you would just do them the solid and use a VPN. So, and that'll always protect you, right? Of course. So let's go over to the kind of set the stage a little bit. So first I'm going to show you the prompt that we are going to be giving to our AI. And so here it is. And so we're going to tell it, say, hey, Claude skills, Claude Code, use your skills. Sometimes if you don't remind it to use the Claude skills, it kind of forgets. Hopefully the models improve on that, because the Claude skills are a little bit new. So hopefully that won't be a problem in the future. But now I always just prompt. I'm like, remember to use your skills. Basically telling it, hey, perform an analysis of the following Android application, give it a path. Use this working directory, talk about that in a minute, and say, hey, I want to understand what the Android app does, and I give it some context of what the device is, and that I was instructed to install this app store, right? And then said, hey, also if there's any API calls about other apps it tries to install, I would be really interested in that. And then tell it to write all of its findings into a markdown document. So up here in the IoT HackBox repo, we're going to run SuperClaude. All SuperClaude does is it turns on this like bypass permissions thing. And then I'm going to paste this in, and we're going to let it run. Spoiler alert, it's probably going to beat us. So right here, we can see the auto analysis directory. That's Claude's directory to do all its work in. And then this manual analysis directory. So first thing I'm going to do is just copy over our APK file into there, and we'll let it do its thing. Gosh, this is like spazzing out up here. Okay, we're gonna like not give ourselves a headache and just kind of hide that for now. So here we go. We're in our manual analysis directory. We have an APK file. So an APK file, if you're not familiar with it, it's an Android application file, and it's effectively a zip file. If we run the file command, it is going to, if I can spell, it's going to say, hey, it's an Android APK package because it's detecting some other metadata inside the file. But if we go and like, let's just say unzip, and let's copy it into the unzip folder. Let's go in there, and then let's just rename this as .zip. Then we can use the zip program, and we can unzip the file and get access to everything that's on site. Now, I want to look at one file to show why we use some of those other tools, and we don't just always unzip these files kind of the way we just did it there. So let's look at this Android manifest.xml file, which the Android manifest file is like the main file inside of an Android application that kind of lays out the permissions that the app has, any services, any kind of like relationship, service relationships, permission relationships it has with other apps on the system. And we will see that this is a binary file. So that's one of the things these other tools is going to help us with. But honestly, a bunch of these other things are resources that we could start doing some reverse engineering on. It's just a little clunky. So what we're going to do is we're going to go back and we are going to use our first tool, and that's called APK tool. We're going to use the D to kind of unpack things, and then -O is like going to put it in an output directory. We'll just call it unpack, and then the App Store. And so what that's going to do is it's going to go ahead and it's going to find, and it's going to see here, right here it says decoding the Android manifest XML file. So that way, when we go in here, unpack, here, let's get that there, and then we have our Android manifest.xml file. There we have the Android manifest in not in its binary form. So here, right off the bat, we see a bunch of permissions that are being requested by this app, and they are a lot. It's, read logs on the system. Okay, so, mount and unmount file systems, that's pretty big. And then all this stuff with anything like an external storage, it can read, write, and manage. So just like it can manage all your storage, and then replace existing packages. That is like pretty powerful, because if there's an existing, like official app, it would have the permissions to install an app over top of it. Yeah, request install packages. Again, it's got all this stuff that it can do, and it can, again, install. I mean, it's an app store, so it kind of makes sense that it's going to be able to install applications, but the malicious nature of those applications is obviously what's most important. And there's some other stuff in here that's not super important. Now what I want to do is I want to take a step back. So inside here we have this stuff called Soli. So Soli is an intermediate language between like Java and Java bytecode. And if I get that wrong, somebody correct me in the comments. That's my rough understanding of it. But the cool thing about Android applications and the nature of Java is that there are a lot of really good Java decompilers that can actually get us back farther. So if we go like look inside of one of these, let's just go down into like one of these directories here. Oh, come on. Soli com. Okay, so like let's just like look at one of these. It's all text. We don't do that. Right? Like this is a text representation of the like intermediate language of the Java bytecode. And so obviously you can read through all this and try to reverse engineer something. It's just really hard to do that. And so we are going to do it another way, and that is to use JADX. So unpack is really, so APK tool, by the way, is really important if you're trying to like unpackage and repackage an application. Sometimes making a small change is a lot easier when it's the Soli code. And so what we're going to do, though, if we want to just like statically reverse engineer something, if we're not going to like repackage it, JADX is really the way to go. And we're going to specify what directory we want to decompile the app into, and then we're going to do deoff to do some kind of deobfuscation. There is a bunch of obfuscation in this application. You kind of saw those strings for ProGuard. That is an Android obfuscation tool. And so we're going to do that and then specify the App Store. And here it's going to, again, attempt to decompile all of this stuff back into Java. So if we go into sources, okay, so we can see a bunch of stuff here, like, but if I just like list out all these directories, right? If I'm just picking a random one, it shows you like Java code, right? This is a lot easier on the eyes. Obviously, you lose some variable names. And this is even worse again because there is obfuscate, like they're actively trying to obfuscate what's going on. But let's, inside the sources here, let's just do a regex search that I have pasted here for any kind of like URLs, right? So here we go. We've got some stuff already. Okay, so some GitHub stuff. That's not super important. Here we have a kind of like a bugly URL here. That is a I'm not like an Android developer, but this is like basically like bug reporting. So it is sending data, you know, like about the application, about the running system back to this server, which if we, you know, get that IP address, we will see that that is hosted in China. And so, of course, of course it is, you know, but it's just good to know that there is, you know, is data being shipped back to China here, and that is not the only domain. And this, okay, so here's something, you see a reference obviously to like a local IP. This is maybe for development. The developers left that in here. It could be used maliciously, not quite sure. And then here is a very interesting string here. So here in myapp.java, so it's kind of like an important part of the application, we have this reference to raw.github user content. This is being hosted on GitHub, store.json. So let's go ahead and view this URL. That's kind of interesting. So if we take this, what is pretty obviously base64 encoded, I'm going to go over CyberChef, and we're going to paste that in, and we're just going to say from base64, and we have some stuff here, which is, I'm going to try to zoom this in for you guys. Now it's all just like hiding behind me. Okay, well you can see here that it's got some App Store related IP addresses, and they're all local IPs, and that is kind of interesting. And I don't completely understand why there are these like local IPs yet. But the interesting thing is that there's another kind of set of App Store URLs that we're gonna find in a minute. But it's clear, like why are you base64 encoding stuff and having it like this? And obviously this repository, right? Okay, so this person right here, if we just go to github.com/, so this is the GitHub account that's hosting these files here, and you can see, you know, it's got these different boxes. Here's, you know, box at, you know, S5 Pro, box 6. So it's clearly all the different SuperBox brands. This GitHub repository, it has something to do with that. And so that's just kind of interesting. So the other thing that I want to look at is this. Okay, this is fun. So let's actually go ahead and look at this file, that this URL, this NBA online service dolet URL is. So let's go and look at that Java code. Okay, so right here it says tracker. Okay, this is a tracker. A tracker for what? A tracker for, oh come on, for torrenting. So clearly, like right here, right out of the gate, we have evidence that some kind of peer-to-peer torrenting is happening. We have, you know, yeah, it's clearly set up to do some kind of peer-to-peer stuff, and maybe it's probably seeding too. So at least it's contributing back to the ecosystem, right? All right. So here, okay, obviously some sketchy stuff, like I'm guessing it doesn't like tell the user up front that it's going to be actively seeding and being a part of a peer-to-peer BitTorrent kind of a thing. So that's fun. There's one more thing. Oh, of course it's done. Yeah, we got beat. We got beat really bad, guys. All right. There's one more thing I want to find, and this search actually doesn't exactly like figure out where it is. So what I'm gonna do is I'm gonna say search for API. Let's like just less that out. All right, so right here in this file, there's some interesting stuff in this source file that we decompiled. So here we have a bunch of URLs, which like I thought this was like a placeholder, but it's not. Okay, so here we have host main, host speech, PTJ, and host APK, which is kind of fascinating, right? So so these again are let's go ahead and let's grab the location for this IP. Okay, so this is behind Cloudflare. All right, well that one's a little more legit, but who knows? But you can see that there's some URL, there's some endpoints here, which is really fascinating. And I don't have like a whole bunch of time to like get into like what's going on here, but you can make requests to these and they return encrypted results. And so there's a whole bunch of obfuscation going on around these IP addresses and what is being communicated back and forth. So I'm really curious. Let's go ahead and take a look at what Claude got us, because okay, and that's kind of why I gave it that prompt to be like, hey, are there any AP? They're like, is there anything interesting going on in the APIs? Let's just go up here. So it completed a comprehensive analysis, right, of the SuperBox APK. Okay, yeah, third-party Android's app store that downloads and installs app from remote server. Fetches apps, lists from GitHub, and custom domains. Okay. Uses AES. Okay. Uses AES encryption with a hard-coded key for API communication. So it thinks that this is the AES key, which that definitely could be it. But I think there's something else going on with the encryption because I haven't been able exactly to decrypt the comms yet. It's a matter of time though. API architecture. Again, this is like, it's just getting this from the source code decompilation and APK tool. It's probably more JADX. It's gonna find this stuff. And again, it found the thing we talked about here, right? It found that it's getting configuration from GitHub. And the thing to think about that is like the person who controls that GitHub repo could change that and then could change what server gets to serve apps to these devices. So that's sketchy in and of itself. So main endpoints, okay, you can get available apps, check for updates, authentication. So this is kind of cool. And then encryption. It identifies that there's kind of a custom AES in a native library. So what we probably are going to have to do is we're probably going to have to load this into, Ghidra, IDA Pro, Binary Ninja to reverse engineer how the encryption is working inside of this native library. So Android again, so we decompiled the Java, but the Java code inside of an Android application can actually call to a native library that's written in like C or C++. So that is where the encryption and decryption for the like payload to this API is happening. It's cool. So it figured out that it's doing that. Downloads APK file to SD card. Okay, that's good to know. And installs apps and can be automatic with is auto flag. Okay, so it's identified that it can just like silently by itself install apps. That's pretty cool. There's some custom DNS resolution. There's all sorts of sketch stuff going on, and it figured all of it out, which is kind of crazy. It's kind of cool. So definitely go and check out not this repo. This repo. So definitely go check out the IoT HackBot kind of tool and play around with it. I'm really, really interested to see other people's results with this tool And so want to thank everyone for watching this video. Please, comment, let me know what you think. And I'm hoping to do a future video where one, I want to decompile that native lib, and then I'm also going to, what I haven't done yet, I'm going to install this piece of sketchy software onto this actual device, and we're going to see what it does on the network. If that sounds fun, be sure to subscribe. Like I said, thank you and have a good day.